Welcome back. This is the second lesson recording for IM2, March 25th, 2021. So we've said that there are 2 minus 1 or 100 minus 2 number of triangles that's formed by a hectagon which has 100 sides, right? So if we are going to be able to form 98 triangles, that means the total sum of interior angle is going to be 180 multiplied by 98, which is 17,640 degrees, a huge number. Okay, so then next, write the formula that can be used to calculate the sum of the interior angles of an n-gon, a polygon with n sides. So to be able to generalize, if you just know that the number of sides of the polygon is n, the number of triangle is going to be whatever that n is minus 2. So then number of triangles multiplied by 180 is going to be the total sum of the interior angles. And that is summarized in this slide. Okay, sum of the interior angles for triangle, we had formed one triangle, form one triangle and therefore 180 degrees. With quadrilateral, we can form two triangles, so therefore 360 degrees. 2 times 100 is 360. 5-sided pentagon is going to form 3 triangles, so 3 times 180 is 540. And hexagon minus 2 is 4 triangles that's going to form internally, so 4 times 180 is 720. And 7-sided polygon, heptagon or septagon, depending on the textbook, is going to form 5 triangles inside. Therefore 5 times 180 is 900, and then so on. Okay, so for octagon, if you have 8 sides, we're going to be able to form it into 1, 2, 3, 4, 5, 6 triangles by drawing 5 diagonals. So the number of triangles I can break a polygon into is 2 less than the number of sides it has. So for n-gon, the polygon with n sides, the sum of interior angle is going to be 180 multiplied by n minus 2. Alright, here are some drawings of polygons that I asked students to make. Polygons and non-polygons, in fact. So do you think that is a polygon? Well, it would have been all except this non-straight side. So this is not. What about this? Well, it's cute, it's really cute, but it does not look like a straight sides. Okay, even just ignoring what's inside. What about this? This is not a polygon because it's not close. See, the sides are not connected. What about this? Well, the lines are not straight, is it? It's close, but it's not quite straight. What about this? We're getting closer, but is it straight? I'm not sure whether that is straight or not. What about this? It's not quite straight, but if it was, it would have been 1, 2, 3, 4, 5, 6-sided polygon. What about this? This is definitely curved, so that's not a polygon. Okay, here it 1, 2, 3, 4, 5, 6, 6-sided. If it was a straight line, yes, it would be a polygon. Again, this, if I just look at the inside figure, yes, it could be a polygon. What about this? The sides are not straight. The sides are definitely straight. Is this a polygon? Yes, it is. Because it's formed by a straight line. And it is closed. And there are no holes. What about this? That is also a polygon with 6 sides. What about this? Interesting. But this is multiple polygons. I see a triangle, quadrilateral, and a triangle here. So multiple polygons, and that is almost a polygon, and these are not. Okay, convex versus concave. When we're classifying polygons, we can classify them as convex or concave. As the name would suggest, concave, the shape caves in at some vertex, while as convex is something that is not concave. So an example of concave is this one. Do you see how the shape caves in right here into inside? So that's why we call this concave, while as this is convex. So with the concave polygon, you're going to have at least one interior angle that is greater than 180 degrees. Notice this angle here, okay? Because of concavity right there, here the angle is going to be greater than a straight line. Straight line is 180 degrees, but it's going to be bigger than straight line, so that's greater than 180 degrees. Can you classify which are the concave? Can you pick out a concave and convex polygons? Well, let's just assume the lines that look like a straight line are straight line. Which are convex? Which are concave? Well, the concave ones are the ones that are caving in, like this one. This is concave, and this is concave. And this is also concave, except this curved line. Let's talk about regular polygons versus non-regular polygon. Okay, so definition of regular polygon is that all sides are congruent and all angles are congruent. So for example, this is a regular hexagon, and you can tell just by looking at it, it looks like very standard hexagon, right? But beyond just looking like it, we need to for it to be called hexagon, they need to have all the angles that are congruent. And we can see that they are congruent because of their marking. They all have one arc, one arc, one arc. That means they are same in measure. And the side length likewise, they have one notches each. That means the side length are also congruent, or they have the same measure. Looking at this is a hexagon. That means it's six-sided polygon. It's a hexagon with congruent sides. The length of each of the sides are the same. However, the angles are not the same. Obviously this angle and this angle does not look the same, does it? Okay, so it's not enough that all the sides are congruent. It needs to be both sides and angle. And looking at this is a hexagon with congruent angles but not congruent sides. You can tell that all the interior angles are 120 degrees, but you can also tell that this length is not going to be the same as this length. So this is not a regular polygon. Alright, so can you tell which is regular, which is not? Well, the only one that could remotely be considered regular would be this, or possibly this. Okay, or maybe this. No, that side looks much longer than this side, so no. So possibly this or this. Okay, and now you're going to go on to card number 13 to 16. So here you have an irregular pentagon here. Can we figure out the measure of the red angle? Well, before we said that the interior angle, or the angles, the interior angles of a pentagon, because it's six-sided, so 6 minus 2 is 4. 4 times 180 is going to be 720. We know that we the interior angles are going to add up to 720. Then can we tell what this angle is? No, we cannot, unless we know all the other angles. If then we can figure out what the last angle is. However, if you do not know any of the angles, we cannot say what this angle is. So no, we can't tell what the measure of the red angle is. What about a regular pentagon? Okay, so in this case, how many triangles are you going to be able to form? Pentagon means it has 5 sides. So 5 minus 2 is 3. 3 times 180 is 540. I know that all the interior angles are going to form 40 degrees. But we know that if it's a regular pentagon, they are all going to have the same measure. So 540 is going to be divided up. So 540 is going to be divided up by 5 angles. And that's going to be 108 degrees. So we do know what angle measure that is going to be if it's a regular pentagon. Okay, card number 15, regular octagon here. That means we have 8 sides. How many interior angles are in an octagon? So 1, 2, 3, 4, 5, 6, 7, 8. So we have the same number of interior angles as the sides. So we have 8 interior angles. So we can say 8 interior angles, and they're all going to be congruent. What is the sum of all interior angles? Well, we know that it has 8 sides. So 8 sides minus 2 is going to be 6 triangles. So I can form 6 triangles. That means that all the sum of interior angle is going to be 6 times 180. That's going to be 1080 degrees. Okay, so what is this sum of all interior angles? That's going to be 1080. 1080. I'm going to submit that. And so each angle measure will be, I know that 180 is going to be made up by 8. So I can do 1080, 1080 divided by 8 is going to be 135. So I know that it's going to be 135 degrees each. Alright, so write the formula that can be used to calculate the measure of one interior angle of a regular angle. Okay, so if I can figure out how do I figure out the total sum? Total sum is however many sides an polygon has. So that's going to be n, and we need to subtract 2. That number is going to form the number of triangles it's going to form interiorly, and so each triangle is going to add to 180 degrees. So that is the formula for the total sum of the interior angle, but we need to divide that by the number of sides because it's going to have the same number of sides as the number of congruent angles. So I'm going to divide that by n. So I can submit that. Okay, so regular octagon, number of sides is 8. Number of angles is also going to be 8. So the sum of interior angles is going to be 8 minus 2, which is 6 times 180 is going to 1080. And we need to divide that by 8 because we have number of angles to be 8. So 135 degrees each. What about regular angle? We can generalize it with n. And number of angles is n. Sum of interior angle is going to be n minus 2 multiplied by 180, which is, okay, and that's not 1080. And so each angle is going to be the total 180 multiplied by n minus 2, and then divide by number of angles, which is n. Alright, so that's it for today. So on your table of content, you should add polygon interior angles and today's date. Thank you for listening.